Okay. In number 18, excuse me, we have two different wheelbarrows, pretty much lifting the same load, and we're trying to figure out what the force that the person exerts on the wheelbarrow has to be. Now, there are two different wheelbarrow designs that distribute the load differently, and we're going to see if there's actually a change, which we're going to realize there is. There's one more efficient wheelbarrow than the other. So we have, let's call this wheelbarrow A and wheelbarrow B. Wheelbarrow A, this is pretty much just the guy holding up, so this is going to be an equilibrium equation, which of course means that the net force has to be 0 and the net torque has to be 0. For the net torque, we're going to use the reference point as the wheel. Because all the forces are acting in the y direction, we don't really care how far above the reference point the forces are. We just care about the forces in the x. The displacement from the reference point in the x, because all the forces are acting on the y. So we look at the net torque. The net torque has to be 0. So we have 525 the force of the load times 0.4 plus negative 60. 60 is because all these forces are going to be causing things to move clockwise, plus F, the force of the guy, times 1.3. He's going to cause a counterclockwise rotation, so that's why he's positive, plus F2, 0. Now, the actual drawing doesn't show F2, but there is a force of the ground being exerted on the wheelbarrow. But since we put our reference point of the wheel, we don't have to worry about that force because it's just going to end up being canceling out. So right now we don't really need to use another equation. Our net torque equation was pretty much all we need. We have one unknown, one equation, even though it's a little bit of a big equation. Kind of clean it up a bit. And then we get negative 210 minus 36 plus 1.3 F. And from there we just kind of solve our force. Our force exerted by the guy for the first wheelbarrow has to be 189.2 newtons. It's kind of a lot for a wheelbarrow. Then we're going to analyze wheelbarrow 2. We're still going to use the same reference point as the wheel. And we're going to start off with the net torque equation. So we're going to do F2 times 0 plus 525 times 0, because both the weight of the dirt and the normal force of the ground are exerted at the same point, which is the reference point, so it's 0 distance away. Plus the 60 newtons times 0.6, and that's going to be negative. And that's going to be plus F 1.3. And then when we clean it up and solve for the force that the person has to exert to pretty much lift the exact same load is only 27.69 newtons. So he only has to use 27.69 newtons to lift something that weighs 525 newtons, and in addition to the wheelbarrow, he's actually lifting 585 newtons. So that's where the design of a wheelbarrow kind of comes into play. Not all wheelbarrows work the same. You have to actually kind of think about them and find that one wheelbarrow actually works better than the other just by design.